We are live. Chair, you have the floor.
All right. Thank you. Okay. Welcome everyone to this class. My name is Emmanuel, and we'll be learning about components in Cairo and how to use components in your smart contracts. So, give me a minute to share my screen so you can see the slide I prepared. Okay. Okay. Can you guys see my screen? If you can see my screen, react with a thumbs up, please. Okay, good. So as I said, I'll be taking you guys through an introductory lesson on Cairo components and how to use Cairo components in your smart contracts. Now, what are components in in the most basic way? Yeah. So as smart contract developers, I believe we are all familiar with the concept of encapsulation from other programming languages. So if you are familiar with the concept, you can please react with a thumbs up so that I know we are following. Yeah, nice. So in earlier versions of Cairo, when it was not possible to encapsulate your code, like code you use, like reusable code that you use to like perform a particular task that you can group into a unit. It was not possible to encapsulate them into like a module and reuse them. So it was always a challenge when you wanted to maybe benefit off a code someone has written already. You basically have to rewrite the code in your own smart contract and import it and stuff like that. So it's error prone, it's not very efficient, and as developers, one of the key principles is do not repeat yourself, keep it always dry. So with subsequent versions of Cairo, components were introduced, and components is Cairo's way of implementing the concept of encapsulation. Yeah. So with components now, you can abstract units of your code into modules, and when you need those modules, when you want to perform a particular task, you just plug in that module into your contract, and you have everything ready to go, and saves a lot of time. You don't need to rewrite the same logic over and over again. If someone has written a logic somewhere already, you can just plug it into your code and use it. For example, we have enable component from Open Zeppelin. We have ERC20 token. I'm sure some of us here are familiar with them. So let's move. So how do we define a component? Now, a component is very similar to a smart contract, but there are some key differences. Like smart contracts, components can have storage variables, components can have events, and they can also have external and internal functions. But one unique difference between a component and a contract is that, unlike a contract, a component cannot be deployed on its own. You have to embed it in a component, and when you embed a particular component in a contract, that component becomes part of that contract code. So whenever you deploy that contract, you get access to the external functions of that component, depending on how you define the components in your contract. We'll get to that later. So how do we create a component? When creating a contract, you decorate your module with these attributes, hashtag, square bracket, Starknet, contract. But in the case of components, You do that with Starknet, double full columns and component, and that tells the Cairo compiler that you are trying to create a component, and whatever logic goes in is responsible for the component. Now, after you have defined the component and you have decorated it with the correct attributes, you need to define an interface. An interface basically is what will expose the external function, the functions you want to users to be able to interact with from outside the contract or module. An interface exposes those functions. So you define an interface that you want your components to implement. And how do you do that? You do that with, it's the same thing for contract, no difference. You do that with by decorating it with the hashtag, square brackets, Starknet, double full columns, and interface. So let's move on to the next slide. Then you need to define your storage variables and your events. Storage variables is what is going to hold the public, more like the public variables that can be just more like the state of the contract that can be altered based on the function being called from outside the contract. And we also have events that are emitted when the state of the component changes, stuff like that. And this is the syntax on how you deploy and you define your storage variable and your events. I just, because of space, I just omitted some things here. Usually here you have your import, bringing in the modules you want to use in the components. For example, you can bring in some types from Starknet, like contract address and whatever. So to define your component storage, you decorate it with the storage attribute as you can see here. Then you create a struct, and usually the struct is called storage, and you can only have one struct per component. Likewise in contracts, and within that storage struct, you can define as many storage variables as you want. Moving on to the events, you decorate it with the event attribute, and you as well derive some traits as well. Here we are deriving the drop trait. That's telling the compiler that when the event goes out of scope, the compiler should drop it. That's a more complex something that's beyond the scope of this lesson, but I just decided to throw in there. And we are also deriving Starknet event trait. And inside that we have our and inside the event we have our ownership transferred event, which is emitted anytime the ownership of this component is transferred. And you can see the struct of the ownership transferred. We have the previous owner and we have the new owner, and all have types of contract addresses. So whenever the ownership of this component is transferred, this event gets emitted. I don't know if you are following. Please, if you are following, react with a thumbs up. Yeah, that's nice. Please, if you have a question, feel free to draw me back. I'll be happy to explain. Okay, so let's move on. Now, after you have defined your storage variables and your events, the next thing is to implement the actual logic of the component. You remember in an earlier slide, we talked about defining the interface of the component, which will expose the functions you want to be interacted with from outside. The implementation block actually implements the interface. So whatever functions you have defined in your interface, you have to implement all of them in your implementation block. And this is how you define the implementation block. You start by decorating it with the embeddable as attribute. And every component must have this, at least one of this implementation block decorated with this attribute. Because when you are embedding your component, this is the name. You can see it says embeddable as ownable. Whenever you want to embed your component in a contract, this is the name you are going to refer to. And this is the syntax for implementing it. Ownable implementation, generic over T contract state, and it must implement this has component T contract state. And after that, we are implementing it for the interface we defined earlier, which is enable interface, and it's generic over component states and T contract state. Most times you don't need to worry about what's going on behind the scenes. You just need to know that this is the syntax you have to use wherever you are trying to implement a component. And sometimes you want to have internal functions where in which you don't want people to interact with you. Only want to call these functions within your component. Cairo also provides a way to do that, and we do that by omitting the embeddable as attribute. Whenever we don't specify an embeddable as attribute, we are telling the compiler that this particular implementation block is internal. And as you can see, it's named internal implementation. And it's generic over T contract state, has component state, and just almost identical with the main implementation. And the decorator up here above the implementation block, generate rate, is telling the compiler to whatever functions you define inside this implementation block, the compiler will automatically generate the traits for those functions so that you can interact with them within the contract or component. Okay, I think you guys will get the hang of it, get a better understanding of it if we actually dive into hands-on code. So I've written a component, an enable component and a contract, and I would love to show you guys how the whole thing works. So let me stop sharing this screen and share my other screen. Yeah. Can you guys see my screen? Okay, nice.
Yes, but the fonts are too tiny.
Okay, I'll increase them, sorry. How does it look now? Is it more legible?
If you can increase it a bit, it will be okay. Just a bit.
Okay. Can you see it clearly now? Are you guys okay with this? Okay. Let's move on. Okay, now this is the ownable component, a basic ownable component I created for this class to explain the concept of components. So on line 1 here, I'm importing a type from Starknet module, and it's called contract address. And it's the standard type for standard contract address in Starknet. Now, this is the trait we talked about that exposes the functions that we want our users to interact with from outside. And here we have 3 functions. We have a function for the owner, which returns the owner of the component. The hyphen and arrow bracket here specifies that a contract address is being returned from this function. So this is a get function, and we are passing in self as a snapshot, which means whenever we call this function, we are not altering the state of the components, we are just reading it. So we need to pass in self as a snapshot. Now the next function is called transfer ownership, and whenever we want to transfer the ownership of our component, this is the function we call, and it takes in 2 parameters. Now this function is a state changing function. So we can't pass in the state of the contract, that's the T contract state now, as a snapshot. We need to pass it in as a reference. I'm sure from your earlier classes of Cairo, you have been introduced to reference and snapshots and how they are passed into functions. The second parameter argument here is the owner, the new owner, as the person you are transferring the ownership of the component to, and the type is of contract address. And the last function is called renounce ownership. That basically is like saying you don't want to own the component anymore, and it just takes in the reference of the state of the contract. Now, I also defined a module for errors that we can use. We have two errors here. We have the zero address owner, which will send to the user whenever a zero address is trying to interact with our component, because we don't want that. And also we have the not owner, which will send to the user whenever the person trying to use the contract and the component is not the owner of the component. So now let's move on to, please, are we following? Okay, please, if you have any questions, feel free to ask. Okay, so now this is the actual module of the component. Like I said earlier, we decorate it with the Starknet, hashtag square bracket, Starknet, double full columns, component attributes. And after that, the compiler knows that whatever precedes this is a component, and we define our component by using the pub and mod keyword and the name of the component, which in this case, we want it to be ownable component. And here, from line 17 to 20, we are importing the modules we are going to use in our component. We are going to be using the zero module from the core library. We are also going to be using Starknet contract address and get caller address functions from Starknet module. And we're also importing this storage pointer read access and storage pointer write access. Now this line here, line 19, is very important. You must, whenever you want to read or write values to your component, you must import this. If not, let me comment this out and so you can see what I'm talking about. You can see immediately the compiler is complaining because we commented this out. Now it doesn't know what to do here, because over here we're trying to read from the component, and likewise here we are trying to read, and here we are trying to write. So this is a very important import. Whenever you are creating a component, ensure you import this, like this module, storage pointer read access and storage pointer write access, as they will allow you to read and write to the storage of your component. Now here I'm importing the errors modules I defined outside the component, and this is the syntax. SOPA is like telling us to go outside the component and look for a module called errors in this file and import it. On line 22 to 25, we are defining our storage variables, and in this case, we just want to have only one storage variable, which is the owner of the component, and the type is of contract address. For the events, we are emitting only one event, which is ownership transferred. You can emit as many events as you want. For example, we have a renounce ownership function here. We can emit an event. Whenever the ownership of the component is renounced. And this is the struct for the ownership event transferred event. It emits the previous owner and the new owner. So the use of events in smart contracts is mostly for UI UX experience. When, for example, you are developing a front end, you have built your smart contract now, and you're trying to develop a front end user interface for it, and You need all this data from the smart contract to actually let your users know what's going on, like more like a feedback. And moving on to the actual implementation of the component, we are annotating it with the embeddable as attributes, as I explained earlier, and we are going ahead to implement the functions defined here. So whenever you have a trait like this, you must implement all functions in the trait. If not, your code won't compile. For example, if I'm to comment out this effects function ownership owner, you can see if you hover around these arrows, you can see not all traits items are implemented, missing owner. So whenever you have errors like this, always read the error message. It can be helpful at times, telling you what you need to do to correct it. So in this case, we are missing one function. We are yet to implement one function, which is the owner function, and the compiler is telling us to do so. So let's revert back. The error is gone. So what's the purpose of this function? This function takes in self, which is the contract state, as a snapshot, the component state as a snapshot, and returns the contract address, which is the owner of the component. So this is how you read from the storage self, the contract state dot owner. Owner is a storage variable here. Where is it? This is it, owner. And read returns the value of the storage variable. If we are to add, let's say, another variable, let's name it color and see. Just give a contact address as well. We need to give a comment here. Now, if you want to read this color variable, you can do the same thing here. You can just come here and say self dot color dot read, and this will return the variable stored in this color variable, the value stored in this color variable. But you can see the compiler is complaining. It's telling us that the return type, the unexpected return type, it was expecting a contract address, but we are returning the basic type of in Cairo, which is a unit type. So most times when you are in Cairo, when you want to return a value, you can just omit the semicolon here, and the compiler will know that this statement here is the return value of the function. So, but we don't want that, so we are just going to take this out and return the owner address of the component. Please, are we following? Okay, nice. Okay, for the second function, transfer ownership. Now this function will change the state of, it's a state changing function, meaning whenever this function is called, the state of the component is updated. So we are going to pass in the component state as a reference. And this is how you do it. You use the ref keyword before the self and the type of this thing, which is component state generic over T contract state. And now it's taking a second parameter here called new owner, which is the owner we want to transfer the component to, the person we want to transfer the component to. First of all, we want to check that the person calling this transfer ownership function is not address 0, because we don't want address 0 calling our functions. And this is how we do it. We use the assert function, and we are negating this value here by using the exclamation mark before new owner dot is 0. This is 0 is coming from, this is 0 function is coming from this import here. If we can control click on this, if you go to yes, this is the module. You can see it has a function called is 0, and it returns a boolean if the value passed into this function is 0. So that's what we are doing here. We are checking if this new owner address is 0. And if it is, we are returning this error to the user, telling that owner cannot be a 0 address. So if this check is passed on line 51, we want to also assert that the person calling this function is the owner. We want it to be so that the owner should be the only one able to transfer the ownership to another person. So we want to assert that, and we are doing that by calling assert only owner on self, which is an internal function we defined down here. Now remember I said if we want to define functions that can only be called within the components, we use an internal implementation for that, which is this whole implementation block from line 62 to 87 is an internal implementation for this component. And any function here can only be called within this component. It cannot be called outside. So we have the assert only owner function here. That's checking if the person calling this contract is the owner. And how are we doing that? It takes in, because it's not a state changing function, we are passing in itself as a snapshot, and we are getting the owner of the component, which is by reading from the storage variable we defined in the storage struct. After that, we are getting the caller of this function, and we are doing that by using the get caller address function we imported from Starknet here. Yeah, so whenever you want to get the caller address of the caller address of the person calling the function, this is the function you use. So after we have done that, we are again asserting that the caller is not address 0 because we don't want that. And on line 74, we are comparing the caller to the owner, and we are asserting that the caller should be equal to the owner. If not, throw an error telling the user that the user is not the owner of the contract. And this is the error here that we are sending back to the user, caller not owner. So if all those checks are passed, we call another internal function here called transfer ownership, and we are passing in the new owner. And let's see what transfer function ownership does. Now transfer ownership is going to change the state of the contract. So we are passing in self again as a reference. We are passing in the new owner. Now we are getting the previous owner. That's the owner of the contract before transferring the ownership. And we are reading from the storage variable called owner. Now we are writing to the storage variable, changing the owner to the new owner. And after that, we want to emit an event telling the user that, okay, yeah, we have transferred ownership to this person. So this is how we emit an event, self.emit, the name of the event, which is ownership transferred, which we defined earlier. And we are passing in the value of previous owner and new owner. Are we following, guys? Yeah, please, if you have any questions. Okay, someone is asking for the GitHub link. Yeah, I will share the GitHub link after the class. Any questions so far? Questions are the only way I would believe you guys are following. No one has any questions?
Okay.
Yeah, okay.
Good evening, sir.
Yeah, good evening.
Yeah, so I wanted to ask, because I know that, okay, for some programming languages, the underscore before the name of a function is just more like to indicate that is private. Is like they don't enforce it. So is it the same with respect to Cairo Starknet? Is it like just a naming convention or?
Okay, yeah, it's the same thing. Oh. In this case, transfer the underscore preceding transfer ownership is just telling the developer or whoever is going to go through your code in the future that this function is private. It's not meant to be called outside the components. Yeah, thank you. Yeah, thank you for that question.
Thank you, sir.
Yeah, Wilfred, you can go on.
So I wanted to ask the difference in syntax between defining internal implementation and normal implementation.
Okay, let me explain that real quick. Now, for normal implementation, we decorate it with this attribute here called embeddable as. And the embeddable as attribute takes in a name, a parameter called like the name of the component. So whenever you want to embed this component in any contract, this is the name, ownable, embeddable as ownable. This is the name you are going to use to embed the component. Now, for the internal implementation, we omit these attributes. We don't decorate the implementation block with this attribute. That tells the compiler that this whatever function is inside the implementation block is private. We don't want to interact with these functions outside the component. Now, how do we do that? We just use generate this attribute called generate trait. Now, what does generate trait do? Generate trait is just a shorthand. Instead of, remember, for this implementation, we defined an interface here called ownable. That's interface of ownable component, and we are implementing this component for ownable. Now, generate trait saves us the stress of defining another trait for the internal implementation. So we can come here and say, we can define another trait called internal trait and have these functions here: initializer, assert, only owner, transfer ownership. Yeah, and transfer ownership. We can have it in the trait. But instead of doing that, we can just use this shorthand, and when the compiler sees this, it automatically generates the trait for all these functions, so that you can use the dispatcher pattern to call the functions. I don't know if you are following.
Yes, sir.
Okay, are you getting it?
Excuse me, sir.
Okay, go ahead.
I want to know if I understand something. So, if we use the generate trait attribute or annotation, it means we don't necessarily need to define the traits before implementing the functions.
Yeah, you don't need to define a trait. The compiler will automatically generate the trait for you.
Okay, thank you.
Yeah, that's exactly what it is. Okay, so any more questions? Okay, go ahead.
Hi, good evening.
Yeah, good evening.
Actually, I have two questions.
Okay.
I wanted to ask to explain lines 41 to 43, the house components, especially the house components part.
Okay.
Yeah, from line 40 to 43.
Okay, so from line 41 to 43 is just is the syntax of how you define an implementation block, and you use the implementation keyword, that is the IMPL, followed by what the name of the implementation block, which is in this case ownable implementation, and from this opening angle bracket to this closing angle bracket is this one is the type of the component. And now this implementation block is generic over T contract state. It derives this T contract state, and this has component is just a trait you need to derive whenever you're defining any components. That's just what you need to know about this trait here. Has component trait. Any component you're defining, you have to implement this. If not, the component will the compiler won't, and your code won't compile. Now, after that, we are implementing it for a trait, which is an interface we defined here. enable interface. Now, this off keyword is telling us that this implementation block is implementing this interface here, and here we are just basically specifying the path to the interface, which is super. Super is telling us to go outside this component and search for an interface called enable and bring it into this context here. And this interface is generic over the component state and the T contract state. So as you write, the more you write components, you just know that whenever you're defining a component, this is the standard implementation for it. And it's the same thing for the internal implementation as well, but with some key differences, because we are not defining it for an interface. We are generating the trait automatically. So we are just using T contract state, not component state anymore, like we are doing here. Component state like we're doing here. We are using T contract state. We are also deriving the hash component trait and of internal traits. You can call this whatever you want. The compiler doesn't care. You can call this private implementation, and you can also change this to private trait, and the compiler doesn't care what you name it. It will automatically generate the interface for this implementation. I don't know if you understood.
Yes, thank you. I also wanted to ask what extensions you are using, because the one I'm using I think is a bit buggy. It doesn't. I don't know how to put it.
It doesn't resolve.
The autocomplete one doesn't have. It's not really helpful per se.
Okay, it's a problem with Cairo. What version of Cairo are you using?
I think 2.8.2 or so. Not sure if that is Scarb or Cairo. Sorry, let me check.
Scarb is Scarb. The latest version of Scarb is 2.8.3, and it comes with Cairo 2.8.2.
Yeah, I use Cairo 2.8.2.
Okay, I think with the latest version of Cairo, they actually made it better, which means your Scarb resolves your code faster, and yeah.
Okay.
How did you set up your Cairo extension? This is the extension, Cairo 2.0. Are you using this extension?
Yes, same one.
Okay, you need to go into the settings, right?
Yeah.
Is your Cairo language server enabled?
Yeah, it is.
Okay, what about, did you specify the path to your Cairo language server and your Scarb path as well?
I don't think so. I think that might be the issue.
Yeah, you need to do that for your Scarb to resolve. You can just type which Scarb in your terminal to get the path of your language server and Scarb.
Okay, all right.
Yeah, when you get that, you can just copy them. Yeah, you're welcome. Okay, so I think we should move on and see how we can use those components in a contract. Why is our compiler complaining? Still 2 errors from me. Okay. Yeah, so now this is a contract I created to demonstrate how we use the components we created here in a contract. Now this is just a basic contract called enable counter, and what this contract is essentially doing is we're just exposing a single function here called increase count, which you can call to increase the counter variable in the storage. Now I won't go, because for the sake of time, I believe past instructors have introduced you guys to contract and stuff. So I'll just explain how the component is being embedded into this contract. Now, to embed this component we created here, which is the enable component, we need to bring the component into the scope, and this is how we are importing it. Use intro to component is the name of the package. If I go to scarb.toml here, you can see the name of the package is intro to components. So inside intro to components, we have the enable components folder here. We also have the enable component inside. That's the yes.
You're finished now.
Yeah, finished. Sorry, my dad came in. Okay, we also have the enable component file, and we have the enable component defined inside. So after we have imported the component into the contract, we declare the component using the component macro, and it takes in three arguments. The path, which is the enable component we imported here, takes in the storage enable. You can just name this anything, and also takes in the event enable event. So after we have declared our components using the component macro, we need to embed the component into this contract. And how do we do that? We do that by using an implementation. We are implementing enable implementation, and we are using the enable component. And remember I said over here, whenever you want to embed this component, this is the name you use, enable. So this is the same name we are using here to embed this component. Now this variable here now contains essentially contains this component. Now, if you notice, the compiler is complaining because it can't find this internal implementation in our component, which is because I changed this from internal to private. So to fix that, you can just come here and change this to private. Yeah, and that should fix it. Let's give Scarb a moment to resolve. Yeah, the error is gone. So now, you'll be curious to know what this attribute here is doing. ABI embed v0. Now, this is just telling the component that we want this implementation to be exposed as part of the construct's ABI, which is basically the functions you can call from outside the contract. We are not using that here because we don't want to. This is an internal implementation, and we don't want to expose this. We want to only call this the functions in this implementation in this contract. So after that, we have a counter variable here in the contract storage. Now we need to define a storage variable to hold the component states. And how do we do that? We first of all decorate it with this attribute sub storage v0 and a variable to hold the component state, and we are bringing in the enable component, which is the path, and we are bringing in the storage. So this is just basically whenever you're building component, this is basically what you're going to do with any components you are embedding. And for the event, is the same thing. We are defining an enum distance event, and we are specifying the enable event, and we're bringing in from enable component event. Now, since this is just like a simple contract, we just want to expose one function which is called increase count, and what this does is just increases the count of this counter variable. And here, now this demonstrates the true power of components. Now we want only the owner of this contract to be able to call this function. Now we have defined an enable component already for that case. We have abstracted the logic into a unit. So whenever we want to we want ownership features in our contract, we can just take this component and plug it in here. And we have the logic for managing the ownership of a particular contract. So now, whenever this function is called, we are going to assert that the person calling this function is the owner of the contract. And how we doing that? We are calling the assert only owner on the component, which is what we defined here. Here in the internal implementation, assert only owner. Now, another thing to keep in note is that whenever the component is initialized, this initializer is called. So in most times in our constructor, in our contract, we are going to have a constructor, and a constructor is a function that is called only once when the contract is deployed. So we are going to define one now. We didn't define that before. We do that like this. Yeah. Constructor. Yeah. And we want to set the value of the owner of this contract. So we are going to click on an argument and go to the contract address. Where is the complaint? Okay, I need to import this from Scarb. Okay, now we want, anytime this contract is deployed, we want to initialize the ownable component. And if we go back to our ownable components here, we have a function, an internal function called initializer, which is essentially setting the owner of the component. And since this is internal, it can only be called from this contract. We are not exposing this function outside, so no one can call this function and tamper with our component. So a good place to do that, to initialize the component, will be in the contract constructor. So now we want to say self.ownable dot initializer, and we want to pass in the owner. Yep. Yeah. Okay, so whenever this contract is deployed, it automatically, we are going to pass in the owner of the owner address, the owner of the component and the contract, and we pass it into this owner initializer, and that automatically sets the owner of the address. So whenever anyone who is in the owner of this contract is trying to interact with this contract, we are going to get these errors we defined here. If the address is a 0 address, this error will be sent back, and if the address is not equal to the owner, this error will be sent back. So now let's deploy our contracts and test it on StackScan. Please, do we have any questions? Are you guys following? Only one person is following. Okay, nice.
Hello, can you hear me, sir?
Yeah, I can hear you.
Okay, please, can you reiterate the purpose of Cairo components, summarize?
Okay, the main purpose of components is to achieve encapsulation, which means you can abstract a particular logic of code that performs a particular task. For example, like our ownable component now is managing anything that has to do with ownership of a particular contract. So whenever you have like a unit of code that you want to manage a particular task, you can just abstract that instead of having to rewrite it over and over again. Just imagine in our ownable counter, whenever we want these features here, we have to rewrite this code again in this whole code here can be written in this contract and it will work. But let's say we want to use the same code in another contract, we'll have to rewrite it again, which is not a very efficient way of doing things. So the best way to handle that is just create a component for it, and whenever you want ownership features in your contract, you just plug the component in and you can call the functions of that component. And yeah, that's basically the power and the use of components. Now, this is just one contract. I can define another contract and still embed this component in that contract and without having to rewrite the whole thing. So that's just the benefit of components, and it's more error, it's less error prone, because if you have to rewrite this code over and over again, high chances are that you are going to make a mistake. Okay, someone is go on.
Okay, yeah. So I'm looking at line 15 now, and I see that there is an annotation for components. So
Yeah.
I was wondering, why can't it just be defined as a simple struct or a simple smart contract and then imported and used, like in Solidity or something?
Okay, Cairo is quite different from Solidity. Yeah. So you can't basically do that in Cairo. Yeah, Cairo was created to write provable programs. So there are a lot of things you can do in Solidity that you can't do in Cairo. Cairo is, let's say, more strict than Solidity. Solidity kind of gives you maybe more leverage to do things, but in Cairo you can't do that. So this is basically whenever you want to define a component, this is just basically what you need to do. Annotate it with the component attribute, and yeah, define your storage and event struct and stuff like that and implement it. Don't worry if you don't get it now. It's usually normal. By the time maybe you practice, most times programming is about practice, getting that muscle memory. By the time you write components, you write one or two components, you start to get start to get a feel of it, and you understand. And you understand it is a very, very powerful tool in your arsenal. And if you go through most code bases in Cairo, OpenZebelin, for example, I'm sure you know about OpenZebelin. They have the contracts for Solidity and they have for Cairo as well. They are all components. And how do we use them? We just import them into our code, and yeah, they already defined. Let me see. Let me stop sharing the screen and let's go to. I think I have visibility tab on somewhere. I'll show you guys some. Okay. Let me share my screen. Can you see my screen? Okay, so this is a component for this is OpenZebelin's component for ERC20 tokens. So now whenever you want to create an ERC20 token, You don't need to write the logic over and again. OpenZebelin has done that already. You can just come here to the documentation and you see how the component is being used here. You can see on this line here, we are bringing the component into this context, into the contract, which is called, excuse me, my token. And basically the same syntax as I have explained earlier. We use the component macro, the name of the component, a variable for the storage, a variable for the event as well. Now they have more implementation blocks here because they want to use, if we go to the actual component file, we'll see that they all have this implementation blocks in their components. We are bringing in the normal basic ERC20 implementation. They're also bringing an implementation for metadata, bringing in an implementation for Camel, and also the internal implementation. And they're defining a storage variable here, just like we did in our own components. A storage, an event here that gets emitted. And this is it, just a constructor, initial supply, recipient contract address, and boom, you have your ERC20 token. You don't need to, if you are to go to the file for this, let's go to the GitHub. Am I going to the right place? Yep, let's go there. Oh, this is the interface. I need the main. This thing. Just this is a lot of code. Let's see how many lines. 374. Now imagine each time you want to create an ERC20 token, you have to basically implement this. You have to basically write this logic every time in every contract you want to have this functionality. But OpenZebelin, with the power of components, have made it easier for us. They have created an ERC20 token component that you can just plug into your contract whenever you want to create an ERC20 token, and just create an ERC20 token with a couple of lines. And the advantage of this again is that most of the code you see here on OpenZebelin have been battle tested, they have been audited, so they are not 100% safe, but I can assure you they will be safer than any version of ERC20 token component you want to come up with yourself, because these are very experienced developers that wrote this. So that's just basically the power of components. Or someone raising their hand. Are you guys following? Okay, nice. So let's go back to, let's deploy our component and our contract and test our component. Let me stop presenting this one. Okay. Can you see my screen? Okay, someone was asking a question in the chat. So, Wisdom, are you there? Is Wisdom still in the meeting? Okay, maybe he left. So let's deploy our contract. I'm going to do that with Starknet Foundry. Now I already defined an account contract which I will use to deploy our contracts. Which is specified. Yep. So, yeah. account. First of all, I want to declare the contract. What's the name of the contract? The name of the contract is renewable contract. This should be the pricing type. Oh, Can you guys still see my screen? Okay, nice. So I entered the contract. Yeah. No, specific contract. Let's give it time to compile. So there's some document. Sorry, give me a minute, guys. Okay, we have successfully declared our contract. Now we need to deploy it. We're going to use this command this time around here. Using deploy plus so.
Sorry. I hear you.
Mic is muted. Can you guys hear me now? Sorry, my mic was muted. So in our counter contract here, we have a constructor, and that constructor is taking in the address of the owner. So we need to pass in this address, this value when we are deploying our contract. So the constructor call data. We pass in the value. I'm going to pass in the value of my development wallet. So now when this contract is deployed, this address will be the owner of the contract. I'm going to enter as there was unexpected argument class hash. Let me look at the documentation.
I think the spelling of the class hash, the spelling.
Okay, let me see. How to get this spelling? Oh, I use double S. I included a H. Thank you for that. Okay, well, our contract has been deployed now. You can go to Starkscan. Let me just share my entire screen. Okay. Can you see my screen? Can you guys see my screen? Okay. Let's go. Sequoia. Let's use the Sequoia. Let me ensure my. So now I can. Let me paste the address here. Okay. So now we can come over to this is to read and write our contract. Now we only have one read function, which is the owner. Now to read the function, we don't need to connect our wallet. We can just click on query here, and it returns the owner of the contract, which is me. And if you compare, this is the same address with my account here. So now let's try and write the contract. For that, we have to connect our wallet. Now, can anyone paste their address in the chat so that I can transfer ownership to them? Are you guys there? Okay, nice. Thank you. Yeah, address works. Same thing. It's all Starknet. Okay. Yeah. So I can write this. Yeah. That's first for start. Okay. The transaction is executing. Okay, it has executed completely. If we go over to the events tab now, we can see that an event was emitted. Basically, this is the event that was emitted when the contract was created. Let's refresh. We should see another event then. Yeah. The events for the ownership transfer, you can see 57 seconds just now, which means it was emitted just now. And if you click on the details, you can see the let me change this to text. Stack scan. I use Vue.js. Let me try Vue.js. English should give us see? Yeah, you can see the data emitted from the event. The name of the event is ownership transferred. You can see previous owner, my address, new owner, the address I just transferred ownership to. Now, the owner of this, I need you to confirm something for me. You can go to StackScan or Voyager.online on your laptop and interact with the smart contract. Now, because I have transferred ownership of this contract, I'm no longer the owner. If we are to read this again, you see the owner is no longer my address. Now, if I am to transfer ownership now back to, let's say I want to transfer ownership back to me. Okay, I have to connect my wallet. Now, let me write. You can see I'm getting the error execution field using caller not owner, and that's coming from the this error we define here, and the assets is coming from here. Transfer ownership. You can see we are asserting only the owner should be able to call this function, and this is an internal implementation. You can see here we are getting the owner, we are getting the caller, and we are comparing it. So now you can see just by embedding that component into this contract, we have the full feature of that component into our, and we can embed it into as many contracts as we want. Whenever we want to do anything that has to do with managing ownership of a contract, we can just use our ownership components instead of having to rewrite the code over and over again. Are you guys following? Okay. So far, so good. Do we have any questions?
Okay. Yes. Yeah. So I observed that in the ownable component, there's a function you declared as an initializer, which you now called in the
smart contract. In the smart contract.
The ownable, which you now called in the constructor of this particular one. Yes.
Yeah.
So I wanted to ask, like, because I think our last tutor was asking him that constructor and initializer, like, what's the relationship between them? Is there any relationship between them at all?
Okay, initializer is just an arbitrary name you give. You can call it whatever you want to call it, but the difference is that the constructor is a unique, and it's a unique like function name in Cairo, and you can only have one per smart contract. So it gets called only when the contract is being deployed. After that, you can never call the constructor function again. So in our ownable components, we have a function. We want to, whenever we are embedding this component into a contract and we are deploying that contract, we want to set the value of the initial owner. So that's just the purpose of the initializer function. We are just setting the initial owner of the contract, and we are setting it to new owner. We can do this in a different way. Instead of passing owner as a variable, we can set it to the person deploying the contract, which we can do by say, we can say let caller contract address equals to get caller address, and we can pass in caller here. I think I need to import this from Starknet. Yeah, this will do the same thing, but the thing is, this is a bit restrictive because you can only set if this is what you want, then fine. You can only set the owner to the person. That's the owner will be the person that deployed the contract. But there are cases where you want it to be a different owner. So most times people just like use a separate like argument for that. Yeah, so you can just get rid of this. So just keep in mind that the constructor of a smart contract is a function that gets called only once, and that's when the contract is being deployed. After that, whatever logic is inside the constructor gets executed. So just intuitively, you know that's like a good place to initialize your components because you know you're doing it only once. So
All right.
yeah,
Thank you.
I hope you get the concept now.
Yes, thank you.
Yeah. Does anyone have any more questions? Any questions? Okay. I guess we are good to go. So I'll upload I'll push the code to GitHub and share the link. Let me do that right away before the call ends. Okay. Okay, I've dropped the link to the GitHub in the chat. So you can play around the components before our next class and maybe try to add your own features and see how it works. So if there are no more questions, I guess we'll call it a day. Thank you guys for joining in. It's been a pleasure. Yeah. So we'll see you in our next class. Yeah, welcome, guys. All right. Good night.
Hello. Please, can someone help me with the slides if there was any in today's class? I didn't join on time, and I'll be needing the slides if there was any for the class.